let's talk about this simple function, okay? Your function f of x is equal to 16 minus x squared, which is continuous function and differentiable, okay? And we're going to try to estimate the area under the graph, graph between 0 to 4, okay? Let's do like this, okay? And then we're going to use like 4 approximating rectangle, okay? But for this problem, we're going to use the equal size of each subinterval, which means your base of each rectangle will be same size, okay? So and also like now, like I gave you like 2 options, right? First one is using the left endpoint for your sample point or the right endpoint for your sample point, okay? We're going to do both of them, okay? So let's start from the left hand point first, okay? Here we go. Okay, so let me give you the figure of this one, okay? From 0 to 4, set face graph, okay? This is your function, then 0 and 4. As you can easily figure out, the 4 is x-intercept, okay? So now, like 4 approximating rectangle, which means we need like 4 subinterval, right? 1, 2, 3, and 4. So again, as I told you, we need just like base and height for each rectangle. For this case, 4 rectangles, right? So like, let's try to figure out the base first, okay? So whenever you want to use the like equal rectangles, then it will be calculated by like this, delta x equal to b minus a over n. B is right hand point, and which is upper limit, and a is left hand point, which is lower limit, okay? And divide by the number of rectangle. So for this case, that is equal to 1. Is okay? So what about height? So for the height, we're going to use the given this direction for the sample point. Okay? Like for the first set, we're going to use the left hand point. Okay? Look at this one between 0 to 1. Your left hand point is 0. Okay? So the function value of 0, I'm talking about this guy. Okay? Will be the height for the first rectangle. Does it make sense? Okay, so the height is f of 0 for the first rectangle, okay? What about second one? Between 1 to 2, right? Your left hand endpoint for this subinterval is 1. The function value of 1 will be the height of the second rectangle, okay? And third one, and the first one, okay? Let me write here, okay? F of 0, and f of 1, and f of 2, and f of 3. These are the height. Now we're done, okay? We know the base of each rectangle, and we know the like height of each rectangle. Is that okay? So now, like let me try to figure out the area, okay? Area can be approximated by base times height plus base times height plus base times height plus base times. That's it, right? That's it. So now what you have to do is we're going to plug in all the function values, and that's it, okay? So f of 0. My function is 16 minus x squared, right? And 16 minus 0 squared, which is 16. And 16 minus 1, 15. And 16 minus 4, which is 12. And 16 minus 9, which is 7. Okay? So when you add up this guy, what is it? 31, 43, and 50, right? And let me come back to the figure. Look at that. Your curve is there, then your rectangle is always over the curve, right? So, like, as you can see, this value is not exact value, but a little bit like bigger than the real area, right? So we're gonna say this is overestimate, okay? Okay. Now let's try to show you using the right endpoint for your sample point, okay? Here we go. So, part B. Okay. We're going to use the right endpoint, okay? For your sample point, okay? So let me draw the figure again, okay? Here we go. Let me try to copy your left side, exactly. okay, and it set phase curve like that, okay. So basically this point is 4, which is x-intercept, and 0, okay, and actually this was 16. Yeah. It was not important, but it's okay. So now we will do same thing, okay. First of all, like from 0 to 4, since we're going to use like 4 equal rectangles, so you have to split like 4 pieces. It is 1, 2, 3, 4, okay? So as we did here, I'm going to do the same thing, okay? The base, notated by delta x, can be calculated by upper limit minus lower limit over the number of rectangle, okay? It is equal to 4 minus 0 over 4. So for this case as well, it is 1, right? Then what about the height? For the height of each rectangle, we have to concentrate on this, okay? The question is to find, use the right endpoint for each subinterval, okay? Look at like first subinterval, 0 to 1. Since right endpoint is 1, the height of this first rectangle will be the function value of 1, okay? I'm talking about this value. So your first rectangle is like that, okay? Then the first rectangle, height is f of 1. The second one, between 1 to 2. Since your right endpoint is 2 for this subinterval, the function value of 2 will be the height of second rectangle. And third one, and the first one is just 0, right? So anyway, let me write, okay? F of 2, F of 3, and F of 4. We're almost there, okay? Now, the area under the curve can be approximated by this way. Base times height, base times height, plus base times height, plus base times height, right? So now let me plug in all these values into function, okay? F of 1 is 16 minus 1 squared, which is 15. Then 16 minus 4, which is 12. 16 minus 9, which is 7, and 16 minus 16, which is 0, okay? So that is equal to, let's see, 27 and 34. Is it okay? So well, now just try to compare, or like before compare this one, okay, let's talk about this one a little, okay? So it is 34, and as you can see in the figure, the area of rectangle is always less than the area under the curve, right? So we're going to say it is lower estimate, okay? Okay, so, well, depend on your sample point, and it could be overestimate, it could be lower estimate, okay? So, but as I told you, like at the beginning of this class, like if you have like infinitely many rectangles, which means that we have like a limit n goes to infinity for your Riemann sum, then overestimate and lower estimate reconverge to the same point, right? Which is exact area under the curve, right?